Hello, welcome back to my channel. We are talking maths and maths. In this video, we are going to look at inequalities, especially solving of inequalities. So let's get straight to the examples and you'll see the steps as we go along. So here's the question. Solve these inequalities and show the solutions on a number line and on an interval notation. So we've got like 3 things to do. Let's start with the first question. We have 12 is less than or equal to x minus 4. And the first step is to change the inequality sign to equal sign. And we've done that here. 12 is equal to x minus 4. Now, you might be asking, why do we have to do that? Well, when we put the equal sign, it is much easier to see the left-hand side and the right-hand side of the equation as well as the inequality, because when using the inequality sign alone, you may not clearly see the left and the right side of the equation and the inequality. And so we use the equal sign. And now to solve for x, we move numbers away from x. Now to move from one side of the equation to the other, we gotta carry out opposite operations. And the opposite of minus 4 is plus 4. So we add 4 on both sides, and that gives us 16 equals x. Now we have just solved like a normal equation. At this point, we can now change the equal sign back to the inequality sign. So we have 16 is less than or equal to x. Right. We have to understand what this small statement means, because when we put it on a number line, the meaning must still remain. Now it is much easier if we put x on this side and the number on that side. So when we do that, the less than sign will become greater than sign. And why is that? Let's understand the meaning of this statement. It says 16 is less than or equal to x. So 16 is smaller and x is greater, since 16 is less than x. If we put x to this side, then the meaning still says the same. If 16 is less than x, then that means x is greater. So x is greater or equal to 16. Okay, we put this on a number line. Here's my number line. Now take note, I could be writing all the numbers around 16, but this is a waste of time and space, so you can just indicate 16. Put a circle above 16, and there are 2 types. One is a shaded one and one is an unshaded one. Now, the type of circle will come from the presence of the equal to sign in the inequality. If x is equal to 16, then we put a shaded circle, which shows that 16 is also x. So 16 is one of the x values. So we shade it, because here it says 16 is also equal to 16. Pardon me. X is also equal to 16. Now the other values of x in the solution will come from the arrow. The arrow will show the other solutions of x. Okay, our solution here says x is greater than 16. And so we point the arrow towards the right, indicating all the numbers that are greater than 60. So all the solutions of x include 16 and 17 and 18 and 18.9 and all the way towards infinity. The arrow doesn't stop there. The arrowhead points that it is continuous. Right. When we put this on an interval notation, We put the lowest x value and the highest x value separated by a comma, and then we close them off with brackets. And again, there are two types of brackets. One is a square one and one is a rounded one. Now the square bracket is used with the numbers, and it's especially used when 16 or the number is part of the x value. In other words, if you look at the solution here and you see the presence of the equal to sign, then you use a square bracket. Okay, since we have the equal to sign there, that means 16 is also part of the x values, so we use a square bracket. Now for the round bracket, we use it always with infinity, and we use it when there is no equal to sign in our solution. Okay, right, for the infinity, which is the highest value of x in this solution, we use a round bracket because we do not know the exact value of infinity. The next example, let's look at example 3 here, where we have x divided by 6 is less than or equal to 0.5. Again, first step, we change the inequality sign to equal sign, so it's easy to see the two sides of the equation. Okay, we have x is divided by 6, so the opposite of dividing by 6 is multiplying by 6, and we must do it on both sides of the equation. Now 6 times 6 as a whole number will cancel out, and will leave us with x. And on the other side, 0.5 times 6 or half times 6 gives us 3. After we solve, we change the equal to sign back to the inequality sign. So our solutions are x is less than or equal to 3, which means 3 is the next value, and every other number less than 3 are also x values. So putting it on a number line, mark the 3, put the circle, and then decide if 3 is also an x value, meaning if 3 is equal to x or x is equal to 3, then your circle is a shaded one. And all the other values of x are shown by the arrow, and since all the other x values are less than 3, we point the arrow towards the left, showing all the numbers less than 3, like 2, 1, 0, -1, so forth and so forth. And the arrowhead shows that the values continue all the way to negative infinity. And now we put it on the interval notation. So we put the lowest x value, comma, highest x value, and we close them off with brackets. Since the arrow points all the way to the left, and since x is less than 3, there's no limit there, it's just less than, meaning everything less than 3. It means we have a negative infinity as the lowest x value, and we always use a round bracket with infinity because we don't know exactly what the value of infinity is. And the highest value is 3, and since 3 is also equal to x, we close it off with a square bracket. Okay, take note, you can see that you can see the lowest and the highest value from the arrow here. If the arrowhead is present, that means it continues all the way to infinity. And if the circle is present, that means one of the values is where the circle stops. So right now it stops at 3. And so the highest value is 3 and the lowest value is negative infinity. Okay, let's go to example 4, where we see a different case. This time we have a negative 96 less than or equal to negative 12x. Again, we change the inequality sign to equal sign. So we have negative 96 equals negative 12x. Now to find x, we divide both sides by negative 12x. We divide both sides by negative 12x. And since we divide by a negative number, take note of this rule. This rule is only it's only specific to inequalities, unlike the normal equations. That's a special case. Okay, when we divide or multiply with a negative number, we change the less than sign to greater than sign, or vice versa, the greater than sign to less than sign. Right, we have divided by a negative 12, so take note, our less than sign will change. So negative 96 divided by negative 12 gives us 8, and these two cancels, leaving us with x, so 8 is equal to x. Take note, I have already changed the sign because I have divided by a negative number here. So the less than sign changes and becomes greater than sign. So now we have 8 is greater or equal to x. 8 is greater, so x is less. Therefore, x is less than or equal to 8. Showing this on a number line, you indicate 8 on your number line, put your circle, and of course you shade it because x is also equal to 8. And shading the circle means 8 is also part of the x values. And of course the arrow shows the other x values. And since x is less than 8, we point the arrow towards the left. On the interval notation, the lowest limit, x is less than 8, so everything less than 8 all the way to infinity, so it's a negative infinity, and the highest x value is 8, shown on the interval on the number line. It's very clear. The arrow stops at 8, so 8 is the highest x value. Now for the brackets, we always use a round bracket with infinity, whether it's positive or negative, because we do not know the exact value of infinity. And with 8, we decide whether it's gonna be a round bracket or a square bracket. And a square bracket means 8 is also a value of x. We get this from the solution, and also from the number line, from the shaded circle. So this is our solution in interval notation. Okay, I hope this is helpful. Now these are all basic inequalities. I will do another video on inequalities containing fractions. So stay tuned, like this video, subscribe, and hit the notification bell so you will get notified when the next video is uploaded. That is all for now. See you in the next video.